discussing this different asymptotic notations. Mute. So we are discussing about different asymptotic notation which will represent the time complexity of an algorithm in mathematical way. We have seen there is big O notation, there is omega notation, and there is theta notation. Big O notation is providing us the upper bound. It means C into Gn. Gn means the time complexity is greater than the actual function Fn. And in case of lower bound, that is omega notation, the C into Gn, that is the time complexity, is less than the actual function Fn. And in case of theta notation, it will provide a strict bound or exact bound from the lower to upper. So we can say this is exact asymptotic behavior. In case of theta notation, we are getting some exact asymptotic behavior of the algorithm. Okay. Now, see, this is a mathematical representation, but in real time or in when we are going to say calculate or we have to represent our algorithm's time complexity, it must be in terms of big O notation. And the calculation of that is little bit not required that much of mathematical information, but some assumption, some intuition you have to implement to calculate the total time complexity of an algorithm. And it will be represented, mostly it will be represented in terms of big O notation. Why? Because big O notation is providing us the upper bound, and we are going to consider the worst case upper bound. For a particular algorithm, we should consider the worst case upper bound. That's why we always provide big O notation, because it is providing upper bound. Along with this, we should provide best case, worst case, and there is obviously some mixed case or average case. Okay. Now, there are different types of, you can say, different values of this time complexity. Some are called order of 1, which is constant. And remember, the order of log n is greater than this. This is logarithmic time complexity. Then order of n, this is called linear time complexity. Then order of n to the power p, which is polynomial time complexity, n square, n cube, anything. Then in between these two, order of n and order of log n to the power p or polynomial, there is another kind of time complexity in between these two, which is order of n log n. Okay. And then the highest of all this algorithm, the exponential, or you can say e to the power n, is the time complexity. So this is called constant. This is called constant time complexity. This is called logarithmic time complexity. This is called linear time complexity. This is also logarithmic. This is polynomial time complexity. This is exponential time complexity. Exponential time complexity. Okay. Remember, this one having the highest value. So if your algorithm is taking order of 1, this is constant time complexity, then you can say this is the best. And if your time complexity is taking order of e to the power n, then it will be called as the worst time complexity. But for a particular problem, it depends. We have already discussed the data sequence and the problem solution. These two will determine what should be your time complexity. Now, we will just try to understand how to calculate the time complexity. Suppose in a program, there is a for loop. There is a for loop where we are using I equal to 0, I less than equal to 10, and I plus plus. And then I'm writing, say, a equal to a plus I. So see, whatever statements are written before this for loop and whatever statement is written after this for loop, that not that much matters, because this two part is almost same for all the codes or all the programs. Suppose in this part we are taking some inputs, in this part we are using some output. So these two parts are not actually considered in any time complexity. So which part is very important in case of any time complexity? This for loop part or loop part is very important in case of any time complexity. See, suppose this part is taking, suppose having three statements. So what is the time complexity? Order of 3. Suppose this part is taking time complexity, say 4 statements are there. So what is the time complexity? Order of 4. So if you add this 2, it is order of 7. So again, it is a constant value. It is a constant value. So this type of constant value always considered as order of n, because we are representing them only. Remember, this will be converted to 7 into order of 1. This is equal to order of 7 into 1. So finally 7 will come out. So it becomes order of 1. So no constant value will be there. Remember this. In case of big O notation, no constant value in the equation. No constant value. So the time complexity of binary search is like this. Order of time complexity is n into n minus 1 by 2. Then it becomes, the equation becomes m squared by 2 minus n by 2. Okay, if I remove the constant terms, it becomes n square minus n. Okay, and then the next property of big O notation is if there is there is two different functions, fn1 and fn2, and we want to calculate the big O notation, then it will be provided like this: max between fn1 comma fn2. I hope it is clear. The big O notation will give the maximum among these two. So which one is the maximum? So there is two different function, fn, this is fn1, this is fn2. Which one is maximum? N square. So the maximum will be represented. That's why the time complexity of bubble sort becomes order of n square. So these are some properties of any time complexity. So the representation of big O notation. So you have to remember this. Now see, so these two are constant. But here, if this one is I less than equal to 10, then again it becomes constant, because we can calculate how many times it will run, how many times this loop will run. But if this value is a variable, suppose n, then see the total time of this part, which is the most important part, will depend on the value of n. Now it becomes dependent on n. So if in your program there is a for loop and there is a variable, not constant value, then depending on that variable, how this variable is changing its value, depending on that, you have to calculate your time complexity. So normally, if you are using a loop variable which is incremental like this or decremental, if you are using, so you can write it like this. So number 1, we can write, if my loop variable is constant, like this, I less than equal to 10, constant, loop variable is constant, then my time complexity will be order of 1, constant time complexity. Okay, now next, if my loop variable is incremental or decremental means increasing or decreasing, and depends on variable n, say n, and there is only one loop or a single loop, then the time complexity will be order of n. Is linear. This is constant, this is linear. So if in your program or code you are using a single for loop, then the for loop value is incremental or decremental, increasing by 1 or decreasing by 1, then we can say that the time complexity is order of n. Now suppose there is a nested loop. Suppose there is a nested loop, one loop inside another loop. Then normally the time complexity becomes like this, order of n to the power c, where what is c? C is number of nested loop. This is number of nested loop. So means, for example, to take some example, then suppose there is a for loop I equal to 0, I less than n, I plus plus. Inside that for loop there is another loop, for loop j equal to 0, j less than n, j plus plus, and then inside this for loop there is another condition, k equal to 0, k less than n, k plus plus. Then see what is the time complexity of this one, order of n. For one particular value of this, it will run n times. So what is the time complexity of this? Order of n square. For one value of this, it will run n time. So how many times this will run? N square time. For one value of this, it will run n times. So the time complexity of this becomes n cube. So among this, which one is the highest? N cube. So what is the time complexity? The time complexity is order of n3. Here I have used how many nested loop? 3. So it becomes order of n cube. Okay. Now, so this is for nested loops. Now suppose in your loop condition, loop variable is divided. Loop variable is divided or multiplied, okay, by a constant, like this. Suppose I'm using for I equal to 0, I less than n, I equal to I by 2, okay, or instead of I equal to I by 2, suppose I'm writing I equal to I into 2, okay. So 2 is the constant value and we are either dividing or multiplying. In these two cases, most cases, the time complexity becomes logarithm, log n. Okay, so these are the different techniques from which we can easily understand what should be the time complexity of a particular algorithm. But we use mostly from the algorithm, if there is a given algorithm, how to calculate. So this is this 3 or 4 times is if one code is given, how to calculate the time complexity. Okay. Now, if some algorithm, some written statements are given, not code, not the total code, then how to calculate? Try to understand. So this type of time complexity calculation is sometimes called recurrence relation. So you have to understand what is the recurrence relation, how the algorithm is performing. Okay. So now let us consider the example of binary search. Okay. If I consider the example of binary search, in case of binary search, what is the algorithm? Algorithm is compare your mid element with the search element, correct? If it is matched, okay. If not matched, then check whether your search element is greater than mid element or whether your search element is smaller than mid element. According to that, what you will do, you will perform a division operation. It means if there are n number of elements, then to calculate the time complexity of n number of elements, among this n number of elements, if your time required is t of n, try to understand. You have to search a particular element from or among the n number of elements. So what is the time complexity representation? The time required to search among the n number of elements. Then what I am doing? I am comparing with the mid element. So how much time will require to compare with single element? It will take a C amount of time, only one statement comparison. Then what happened after this comparison? Your total array, if there is n number of elements, after comparison with the middle element, now it becomes two different parts. It is divided into two parts. This side almost n by 2, this side almost n by 2. Clear? Now among these two parts, depending on this, whether your search element is greater than mid, if your search element is greater than mid, then you will move into this part. If your search element is less than mid, you will move into this part. It means now how much time is required to search? Now you are searching in n by 2 elements. So I can plus t of n by 2. So this is the recurrence relation. Now how to measure this recurrence relation? Again, for a binary search, for searching a particular element in n number of elements, among the n number of elements, the time required is t of n. To do that, what I have performed, I have compared with the mid element. So the time required to perform the mid element comparison, done. Now, after this comparison, your total array is divided into two parts. Either you will choose the left side or you will choose the right side, depending on this condition. So now you have to again search in how many elements? In n by 2 elements. If the time calculation to search in n elements is tn, then the time calculation to search in n by 2 is t of n by 2. So this is the total recurrence relation. Now, by using some substitution method, we can solve it. See how we can substitute. So in this tn, I will put n by 2. So I will get t of n by 2, and this equation becomes c. Sorry, this equation becomes c plus t of n by 2 by 2 means 2 square. Okay, so if this is equation 1, this is equation 2. Now I am putting 2 into 1. Putting 2 into 1, what I will get? I will get tn equal to c plus, for tn by 2, I am writing c plus tn by 2 square. So it becomes 2 into c plus t by t plus t of n by 2 square. Okay, so this is my equation number 3. Again, I am checking again. So this is substitution method. So again, I am substituting n by 2 square. Then what I will get in this equation? I will get c plus t of n by 2 cube. So this is suppose equation 4. So now I am putting 4 in 3. What I will get? I will get tn equal to this one, equal to 2c plus, for instead of t n by 2 square, I am writing c plus t n by 2 cube. So from this I will get 3 into c plus 2 n by, sorry, t of n by 2 cube. So this is my equation 5. So see, after first iteration, it becomes like this, n by 2 to the power 1. After second iteration, it becomes n by 2 to the power 2. After third iteration, it becomes n by 2 to the power 3. And how it is, the c is changing, 1c, then 2c, then 3c. So if we continue in this way, after k times, what will be the value? The value will be t of n. See, after one time, 1 into c plus t of n by 2 to the power 1. After 2 times, 2 into c plus t of n by 2 square. After 3 times, 3 into c plus n by 2 cube. So after k times, it becomes k into c plus t of n by 2 to the power k. Correct? Now see, when we are dividing the array again and again, so if we have started with 8 elements, after first division, it becomes 4. Then the second division, it becomes 2. Then the third division, it becomes 1. So after some time, it becomes single element. When it is single element, this is the end of your comparison or end of your loop condition. Okay, it means by dividing in this way, after k times, the array size, this is the array size becomes 1. It means n by 2 to the power k becomes 1. So this equation becomes T of n equal to k into c plus T of 1. Now, T of 1 means there is only one element and you have to search for a particular element. So if there is only one element and you are searching a particular element, then how many comparison is required? Only one comparison. So it becomes k into c plus c. C is for one single comparison. Okay. Now from this, we have to calculate the value of k. So n by 2 to the power k equal to 1. It means 2 to the power k equal to n. It means k equal to log of n. Clear? Now we have already told, I have already told that in big O notation there will be no constant term. We have to remove the constant term. So from this we can say this is equal to k into c. Then again we can say it is equal to only k. So what is the value of k? The value of k is log n. Correct? So what is the time complexity? T of n is equal to order of log n. So this is the actual technique to find the time complexity from for an algorithm. The concept is called recurrence relation. And how I have solved the problem? I have solved the problem by substituting the values. There is another way. The same problem can be solved in another way. There are n number of elements. This is called division method. So from n number of elements, after first iteration, it becomes n by 2, n by 2. I have to choose either this or this. Suppose I am choosing this one. So after second iteration, it is again divided and it becomes n by 4, n by 4. So this is after first iteration and this is after second iteration. Similarly, among these two, I will choose one of them. So suppose I am choosing this one. So after third iteration, it becomes n by 8, n by 8. So in this way, it becomes, after some iteration, it becomes 1. Okay. It means after some iteration, it becomes 1 means, let us assume after k number of iteration, it becomes 1. So it means n by 2 to the power k equal to 1. It means how much time we required? We required k iteration. That is the time complexity. K number of times you are repeating this. So it becomes k equal to log of n. So this is the actual division method based time complexity calculation for a particular algorithm. You can use for your algorithm, you have to use either this recurrence relation based method or you have to choose this division based method. But see, this division or recurrence relation based methods are very useful in case of divide and conquer type algorithms. Okay, but you can use it in other brute force or other algorithms also. But this type of algorithm time complexity calculation is actually performed in case of a given code. If some code is given, what is the time complexity? In that case, you can use this type of thing. This whether it is loop variable is constant or not, whether the loop variable is incremental or decremental, how many nested loops are used, whether the value loop variable is multiplied or divided. Based on this, you can easily calculate the time complexity. Okay. Now, the next thing that I will try to solve, that is, I hope you know how to calculate max and mean from an an unsorted array. Okay, so I hope you know how to calculate max and mean from an unsorted array. So, what is the max and mean? Max and mean is actually performed in case of a given code. If some code is given, what is the time complexity? In that case, you can easily calculate the time complexity. you know the technique. What is the technique? If I represent it in for loop or in a code, it is like this: m of x is equal to a of 0. I have considered first element as the maximum element. Then we'll run a for loop where I will start from the next element, that is index value 1, and then I will go for n number of elements. Okay, then I plus plus, and then what you will do, you will check whether this maximum value is less than any other value or not. If this maximum value is less than any other value, then this variable or this value becomes the maximum, and this way I can calculate the maximum element. Now suppose if I want to calculate both max and mean in this program, then after this max calculation, what I will do? Again, I will choose the minimum as a of 0. Okay, then for loop I equal to 1, I less than n, I plus plus. Then if mean is greater than any element, then mean becomes that element. So this is the calculation of minimum. So I am doing same thing, only using a different condition, mx less than and mean greater than. Okay. Now what is the time complexity? If I told or this program is given and you are asked to measure the time complexity of the whole program, then what is the time complexity? Now see, if I calculate exactly how many times this loop is running, then we can easily calculate the time complexity. How many times this loop will run? This loop will run n minus 1 time. Correct? Is it clear? N1. See? Please answer me. I have already considered this one as maximum. So if there are n number of elements, then I have already considered the first one as the maximum or minimum. Then how many comparison I have to perform? I have to perform n minus 1 comparison because I have to compare this with the rest. So how many times this loop will run? It will run n minus 1 time. Clear? So what is the time complexity? What is the time complexity? According to big O notation, there will be no constant term. So it is order of n. Clear? Now for this part, how many times it will run? The for loop, n minus 1 time. Again, what is the time complexity? Order of n. So what is the total time complexity? The total time complexity is order of n plus n. So it becomes order of 2n. Again, no constant term. So the final time complexity is order of n. Okay. But what is the exact time? If I say what is the exact time, it is Tn equal to n minus 1 plus, sorry, not Tn, better it will be Fn plus n minus 1, the actual function time complexity. It is 2 into n minus 1. So this is the actual function. And see, we have converted this actual function into a big O notation order of n. Why? Because this is linear time complexity. The curve will be a linear curve, and the time complexity is depends on this value n. Logic clear? Now you have to means suppose the array is sorted. Suppose the array is sorted. Can you tell me how many comparison I have to perform to select max and mean? Anyone, please. So for the first part, it is unsorted. Now, if the array is sorted and you are asked to select the max and mean, how many comparison you have to perform? Please tell me. Anyone? Otherwise, I will. বলো কে বলছো?
Sir, n-1 ही হবে.
If it is sorted. Okay,
Yes,
good.
but we have to do the for loop.
1, sir, 1.
O of 1.
Who told 1?
I.
I মানে তো আমি তো I বুঝবো না, এখানে সবাই I. Saurabh Prasad. Why Saurabh 1?
Sir, if it's sorted, we'll exactly know that the first position will give the minimum and last position will give the maximum.
Is it so? Is
But
it
sir, we have
always?
to do the
If it's sorted in ascending order.
Right. So what you have to write to select max and mean? How you don't know whether it is ascending order or descending order, but it is sorted. Then what you have to write to select the max and mean? Please, anyone?
We can compare the first and the last element to know whether it's ascending or descending.
Very good. Thank you. So you have to write if A of 0 is greater than A of n-1. Simply I have to write this. If this is true, then obviously mx is A of 0 and mn is A of n-1. Else the reverse. So this is the thing you have to write if it is shorted. Okay. Now I am giving you one interesting idea how to perform max mean with minimum time. See, this is a very interesting solution. So suppose I'm considering there are even number of elements. You can do it in odd number of elements also, but let us assume for simplicity there are even number of elements. Now what you have to do, see, you have to compare the adjacent element, this two, then this two, then this two, then this two, then this two, and then this two. Only the adjacent element. And what you have to do after this comparison, you will put the minimum in this position and maximum in this position among these two. Suppose that these two elements are, one is 2, another is 1. Then your minimum will be in this position, maximum in this position. Similarly, among these two, the minimum in this position, maximum in this position. In this way, you have to perform the operation. The first for loop. Now tell me, how many times this for loop will execute if there are n number of elements? Anyone? How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here n is 6. How many comparison I have performed? How many times I have compared? 1, 2, 3, 4, 5, 6. So it is n by 2, correct? Any query? I hope it is clear. So now, what is the next step? In the next step, what I will do, I will only compare this with this, with this, with this. One, I'm jumping or rejecting one element and going for the next. Among this 6 element, I will search which one is the minimum. So how many times is required to select the minimum? N by 2 minus 1. And then, since I have already put the maximums in these positions, so I will check this positions to search the maximum element. So how many comparison is required? N by 2 minus 1. So if I add all these 3, then it becomes 3 into n by 2 minus 2. Now in previous case, for max mean, it is 2 into n minus 1. Now if the value of n is say for this example, it is 12. So for this, how many comparison we have performed? It is 22. Now if I put the value here, it becomes 12, 6, 18, 18 minus 2, 18 minus 2, it becomes 16. So for N12, see, For my first algorithm, it is required 22 comparison. In my second algorithm, it requires 16 comparison. Now suppose n is 100. So for my first algorithm, how much time is required or comparison is performed? It is 2 into 99 means 198. Correct? Now in this case, it becomes 50, 150 minus 2, it is 148. So see the difference. So this is a new algorithm for selecting max and mean from an array. Whether it is sorted, not sorted, we have no idea, it is unsorted. But previously the unsorted algorithm is taking this much amount of time, actual time. Now it is taking this much amount of time. And from the value, you can easily see that this one is better. But what is the time complexity? Upper bound? For both the cases, the upper bound is order of n. So you can easily understand the difference between actual time and the time complexity. Because time complexity always give you the worst case minimum value. So that's why the time complexity is a different thing. Okay, now I will provide you some code. From that codes, you have to measure the time complexity. So write it down. So let us write like this. So this is problem number 1. For suppose I am writing I equal to 0, I less than n, I plus plus, okay, and inside this, suppose I am performing some operation, say x, I'm printing some value of x. Then after this, there is another for loop where I have used j equal to 0, j less than n, j plus plus. Then there is another nested for loop inside this j, that it is k equal to 0, k less than n, k plus plus, and inside this I am supposed performing some operation. Then you have to calculate what is the time complexity of this algorithm. Okay. Similarly, I am giving another problem. So only few seconds are left. Please rejoin for only for 5 minutes. Please rejoin only for 5 minutes to give you some assignment, or you can homework to solve what should be the time complexity. Okay, the next one, suppose it is written like this: if I'm using some if condition, say L less than say 10, then some operation is performed inside there, and in the else part, here is one for loop. Suppose it is I equal to 0, I less than n, I plus plus, and then it is performing say some operation. So this is if and this else. Now you have to calculate the time complexity. Okay, let us take few more examples, or you can say assignment or homework. So suppose for loop I equal to n, I greater than 1, I is equal to I by 2, and then it is performing some operation. So what is the time complexity? So this is 3. What is the time complexity? Now let us take another example or problem. Let I equal to 1 and say s equal to 1, then a while loop, and inside the while loop s is less than equal to n. Okay, then I plus plus, inside the while say s equal to s plus I, and then so now you have to calculate the time complexity. Okay, please write down these problems. I will share the video within tomorrow. So let us take another example or problem. So for now, suppose it is 5. Say, suppose it is like this: for I equal to 1, I into I is less than equal to n, okay, and then I plus plus. Now you have to calculate the time complexity, okay. Then another problem, say this is a little, suppose for say I equal to n by 2 starting, then I is less than equal to n, then I plus plus, then inside this for loop, a nested for loop for j equal to 1, j plus n by 2 say is less than n, then j plus plus, and then inside this for loop another for loop, k equal to 1, k less than equal to n, then k plus plus, and then it is performing some operation. You have to calculate the time complexity, okay. So these 6 problems I'm try to solve the time complexity for these 6 problems, okay. So you have to what you have to do in these problems, you have to check how the values are changing, how the along with the iteration, how the value of ij is changing, how many times or how many times the value of ij is executing. So depend on that value, whether it is depend on n or not, then according to that you have to calculate or you have to measure the time complexity. Again, you need these things when you are calculating the time complexity. You need to remember these things. You need to remember these things. When we will get constant, when we will get linear, when we will get uh, uh, polynomial, when we will get the logarithmic time complexity. These things you have to remember. Okay. And I hope this max min problem is pretty clear to you, how to solve the problem in a different way so that we can get a less total time, not the time complexity, less total time. Okay. Now see, remember a few things that I have already told. There is best case, worst case for a particular algorithm depend on the data sequence, but there is some algorithm which are not dependent on the data sequence. Whether it is best case or worst case, it will always give you the same time or exact time. And remember, those algorithms will be called as the means you can say robust algorithm. Why we are telling them or saying them robust algorithm? Because they are giving you exact time complexity, whether it is in the worst condition or in the best condition. That's why those type of algorithms are called robust algorithms. Okay. For sorting, for searching, there are few robust algorithms. We will discuss about this those algorithms in the later classes. Okay. With this, I'm ending today's class. I hope you have understand how to represent the time complexity, and I have given some questions. Please try to solve this question so that your idea of time complexity will be clear. I will give you more examples or more problems like this in our next classes. Okay. With this, bye bye.